In this video, I'm going to show you how to identify sedimentary rock using the scheme for sedimentary rock identification on page 7 of the reference table. The first thing you want to look at is texture. And there are 3 different types of textures for sedimentary rock. Clastic, which is, you can see there, fragmental, which means different size pieces of rocks that have been broken down, or sediments. Crystalline, which is forming from a chemical sedimentary rock from evaporites and precipitates. Or bioclastic, meaning it has living pieces of materials in there, such as shells or plant remains. So in the lab that you're going to do in class, we are only going to give you clastic or bioclastic sedimentary rocks. So you really are just going to look for, do I see pieces or do I see shells or plants in it? And technically you can't really see the plants in the coal. You should be able to pinpoint which one is coal. So let's start with our clastics up here and determine different grain size. So pebbles, cobbles, and boulders embedded in sand, silt, and clay. Sometimes you can call that gravel. That's going to be a mixture, but you are going to see very large size sediments in them. So when you look here, that's a sediment and that's a sediment. They are larger in size, larger than our sand, which the size is right here. There are 2 options when you pick gravel. You can have rounded fragments or angular fragments. When you look at these 2 samples, hopefully you're able to see that these ones are rounded, making it the conglomerate, and these ones are more angular, which is your Eureka. Next would be sand size sediment. Okay, so a little bit smaller, and you can see these sand size grains in this. If I ever ask you about the range of grain size, I'm looking for this number right here. So technically we could measure these grains and figure out if they were sand sized or not. But if you feel like they are, then you know you're looking at sandstone. Silt and clay are not visible to our eye, okay? So if you just are looking at a rock and you don't really see sediments, and you definitely don't think it's coal or you don't see shells in it, then you know you're looking at either siltstone or shale. So these are the sizes again that we could look for, but we would need some kind of magnification to see that. So what I suggest is go over to these comments. Siltstone is just very fine grain, and shale may split easily. So if you take a look here, you can see this one has split a little bit. And if you're familiar with shale in our area, we have a lot of it, you'll know that this is definitely it. So this is your shale right here. Again, you can't see the individual grains because they're clay size, super small. And this is siltstone. It's a little bit bigger grain, but you still can't see individual grains in it. Some students will take a look at these imprints of fossils and they'll try and tell me that it's bioclastic. It's only going to be bioclastic if you actually have the living piece inside of it. Okay, so this is just imprints here, so this would just be your siltstone. Okay, so when you do your clastics, you're looking for the size, and then you're using the rest of the reference table to help you figure that out. Now if you're ever given a diagram and asked what type of rock you're looking at, you're going to use this map symbol here. Okay, so keep that in mind as you move through. There are map symbols for the other textures as well, but keep those in mind if you're ever looking at a diagram of rock. So crystallines we're not going to take a look at in the lab, but the big idea here is that they form from chemical precipitates and evaporites. So there's rock salt, rock gypsum, dolostone, and limestone can be both crystalline or bioclastic. So there's a version that is formed from precipitates of biological origin, and the one that we have in lab, which is bioclastic, where you're going to see cemented shell fragments. So let's take a look at those 2 bioclastics. First we'll start with coal. Compacted plant remain. Obviously you can't see plant remains in this, but hopefully you know what coal looks like. So this is your bituminous coal, the sedimentary version. And then this is your limestone. So in the inside here, you can see the pieces of shell that are put in here. It looks like it's forming in the ocean, right? So you can see that look. It's definitely different than this, right? Which is your pebbles. So these are our shells inside there, mixed with sand and other sediments, but there is that bioclastic region. So pretty simple chart. All you have to do is determine texture and then head over to your grain size and then your comments, if that makes sense.